Hi everyone, I am here to write code in Python that finds the count of prime numbers below the given number n. So this is there in lead code problem number 204, and this problem is labeled as medium level problem, and now we will attempt to solve this problem using sieve method. So first let me tell something about this problem. This is count primes problem. Count primes. Count primes that are strictly less than given n. So the problem statement will be like, given an integer n, find the number of prime numbers that are strictly less than n. Example, if n is given as 10, the output will be 4. Why 4? The prime numbers that are strictly less than 10 are 2, 3, 5 and 7. Another example, if n equal to 4, the output should be 2. Why 2? The prime numbers that are strictly less than 4 are 2 and 3. Next, suppose n is given as 0 or 1. The output should be 0. Why? Because there are no prime numbers below 0 or below 1. Next, suppose if n equal to 2 also, if n equal to 2, the number of prime numbers that are strictly lesser than 2 are 0. For this case also, the output will be 0. And this is lead code problem number 204, which is of difficulty level medium. For this, we can apply sieve method. The sieve method and its explanation is given in another video, and in some other video I have coded this sieve method in Python. So those who are interested in that, they can see those videos and then come back to this one. If you already know sieve method, you can directly proceed with this code. Then let me find out the number of prime numbers that are strictly lesser than the given value n. For this one, I will be writing a function by name count primes. It takes one parameter, that is n, an integer. N is an integer. Count primes n. According to our sieve method, what is that we do first is, we will take one primes array which is set to true in each and every position, and I am taking n here. Instead of n plus 1, I am taking n. Why? Because I don't want to include n. We have to find the prime numbers that are lesser than n. That's why we give n here. Then we will start with I equal to 2, and while I square less than n. Here also less than or equal to is not necessary, less than n. So this logic is quite similar to our sieve method. I am considering the same sieve method with little alterations in this code. While I square less than n, if primes of I, then start from I square onwards, go up to n, and then every multiple of I is to be struck off. For k in range I square, here also I will be taking n instead of n plus 1. Then make this primes of k as false. Then increment I value by 1. If we do not increment, it will fall into infinite loop and we will get the error like time limit exceeded. Then now we are done with this sieve method. That primes table or primes list is filled with trues and false. Non-prime numbers will get the status false and prime numbers will get the status true. Now we have to make an attempt to count the prime numbers or the numbers whose status is true in primes list. Whenever we come across with one new element which is prime, this count is to be incremented by 1. As usual, I am starting count with 0. Then there are special cases like if n less than or equal to 2, return 0. This is like a special case. Why? If n is equal to 0, we should give the output as 0. If n is 1, we should give the output as 0. If n is 2, there are no prime numbers that are lesser than 2. That's why for that also the result will be 0. For all these three cases, we have to return the output as 0. Otherwise, or we need not write this else also. For I in range 2, comma n. So we will be starting with 2 and we will go up to n. We will be collecting all the prime, not collecting, we are not interested in finding the prime numbers. We are interested in finding the number of prime numbers. So we will be observing, so what are the prime numbers in the range 2 to n. If primes of I, then increment count by 1. Count equal to count plus 1. Finally, return 0. Sorry, not return 0, it is return count. So this is the function which will give the count of prime numbers that are strictly lesser than n. Now let us write driver code here. We will read the input from keyboard, int input, enter n. Then I will be holding the count value, count of prime numbers that are strictly lesser than n in P by calling the function count primes. I am calling the function count primes with parameter n. Here I must say it is not parameter, it is to be called as argument. So while writing the function we call that as parameter. While sending the actual value to the function we call it like argument. So here I must call n as argument to count primes function. Now we got the output and that is stored in P. We have to display the result. Print number of prime numbers that are, as this is exceeding the line, let me just, for the sake of visibility, better visibility, I am breaking this sentence here. I am ending with space. In the next line I will be writing the remaining part. Print number of prime numbers that are strictly lesser than n. The actual value is to be printed here. R, comma, P. So this is the driver code. In this driver code, we read the input from the keyboard and we call the function count primes by sending n as an argument. Then the return value is stored in P and we are printing that P with appropriate message. So this is count primes method. Let us run this code and uh, let us come back to the explanation later. N. Suppose if I give 10, what is the output expected? 4. We must get 4 if our code is correct. Yes, we are getting it correct. Number of prime numbers that are strictly lesser than 10 are 4. Then let me run this again and check with other different test cases. So for any n value that is lesser than or equal to 2, must give the result 0. Yes, we are getting it. Let us run the code. We all know that the prime numbers that are in the range 1 to 100 are 25. 100 is not a prime number. All the prime numbers will be lesser than, strictly lesser than 100. So that's why if I give 100 here, I must get 25 as answer. Number of prime numbers that are strictly lesser than 100 are 25. Yes, our code is working fine and you can attempt this problem in LeetCode. The problem number is 204. So this is all about the count primes program and we did that implementation in Python, and you can go through this one by pausing this video and you can get to know how this sieve method is implemented to count prime numbers. Thank you.